Hello class, today we're going to be talking about derivatives of inverse trig functions. So first, let's just recall our trig functions. We have six that we're going to talk about. We have sine, cosine, tangent, cotangent, secant, and cosecant. Remember how these work. The input of these were all angle measurements, and our output were the ratio of sides of a triangle, of specifically a right triangle. Well, our inverse trig functions are those, but they are, well, they're the inverse. Our input is the ratio of sides of the triangle, and our output is the angle measurement that creates those ratios. And the inverse trig function can be written or denoted by a little -1 in the exponent in between the name and the variable. I'm sure you've seen it before. It's probably just been a while. This is called arc sine, arc cosine, arc tangent, arc cotangent, arc secant, and arc cosecant. You may also see them written like this. Let's see. Like instead of this, you may also see them written as arc sine of x, or just written out arc in front of it instead of the -1. But when it comes to taking the derivative of inverse trig functions, we have some nifty little rules for us, and that is here. I would recommend writing this down somewhere handy so you can reference it. Now, the u is just whatever the input is, or yeah, whatever we're inputting. And so, like for instance, sine or arc sine, or the derivative of arc sine of u, is u prime over the square root of 1 minus u squared. The derivative, or d du of arctan u, is u prime over 1 plus u squared, and d du of arcsecant u is u prime divided by u times the square root of u squared minus 1. And u prime, if you have forgotten, prime is just, remember, the derivative. So we will be having to take the derivative of whatever is inside. Now notice these on the right here. There's a relationship between them horizontally. The relationship between arc sine and arc cosine, or the derivative of each, is that cosine is just negative. It's the exact same thing. And same thing with cotangent and tangent. Well, sorry, arc cotangent and arc tangent. The derivative is just negative as opposed to a positive here. And the same thing with arc cosecant and arc secant. This is just the negative version of this. So keep this handy, and we will use it as we go through today's lesson. So let's talk about some examples here. I'm going to start with y equals arc sine of x. And I guess off to the side, just so we have it, I can write the rule here. I'll write it in whatever this color is. I'm not very good with colors. Okay. d du, is that lavender? I don't know. Arc sine of u is equal to u prime over square root of 1 minus u squared. So first let's define u and let's define du, okay? And then we can just plug it right in. So in this case, let's see what color. In this case, u is just x, and u prime, or du, is just 1, the derivative of x. So now we have everything we need to plug it in. So d du of arc sine of x is equal to u prime. So our u prime is 1. So it's going to be 1 over the square root of 1 minus u squared, which u is x, so it's just going to be x squared. and that's the derivative of arc sine of x. All right, let's go on to the next one. Here we have y equals cosine of 3x squared plus 2. And again, I will write in lavender up here the rule here. So it's d du of arc cosine, of u is equal to negative u prime over the square root of 1 minus u squared. So again, let's define what our u and u prime are. So u is just this 3x squared plus 2. And u prime is the derivative of this. So this is going to be 6x using the power rule. And the 2 goes away. So now we can just plug it right in. So d du of arc cosine, oh, sorry, I goofed. We're not doing u anymore, we're doing x, right? Because we're defining these as x. Sorry, yeah, if there's an x, then there should be an x there. So d dx of arc cosine of 3x squared plus 2 is equal to negative u prime, so that's going to be negative 6x over square root of 1 minus, and then in parentheses, u prime. We need to make sure we have parentheses in there. 3x squared plus 2, and that whole thing gets squared because it's u squared. So, extend my bars there. Okay, perfect. So that's the derivative of, ooh, I'm goofing all over. This should have been arc cosine. That's the derivative of arc cosine of 3x squared plus 2. Now let's talk about the y equals arc secant of 6x minus 4. Again, I'll just write the formula here so we have it. So d du is equal to arc secant of u. Oh, not equals. Dang, I'm goofing all over. Sorry. Now it equals, let's see, what was secant? It was u prime divided by u times the square root of u squared minus 1. So again, let's define our u and du here. So u is going to be 6x minus 4. And u prime, or du, is going to just be 6. So again, we can just plug it right in. So d dx, I'll use orange, d dx of arc secant of 6x minus 4 is equal to u prime, so that's going to be 6, over u, which is, probably need to make this a little longer, u, which is 6x minus 4, times the square root of u squared minus 1. 6x minus 4 squared minus 1. And that's the derivative. All right, let's talk about one more here. So now we have the function y equals 3x squared plus arc cotangent of 8x squared minus 3x. So again, I'll go ahead and write it for us. So d du of arc cotangent of u is equal to negative u prime over 1 plus u squared. Okay, so let's first define, well, first notice this. This right here would go, well, I'll talk about that in a second. Let's first define our u and u prime. So u is going to be 8x squared minus 3x And u prime is, we're just going to use the power rule. It's going to be 16x minus 3. So let's talk about the derivative here. So we could, well, this will just take the power rule. So this is just something extra. But we can say that dx of 3x squared plus arc cotangent of 8x squared minus 3x equals, we could just do this part just like the power rule, so this is going to be 6x, and then plus our cotangent. Now we'll need to use this because we're just, this is just concerning the cotangent or arc cotangent. So negative u prime, so it's going to be negative 16x minus 3. Let's see. I guess I could have put a minus here, but I'll just put it up here. So negative 16x minus 3 over 1 plus u squared. So 1 plus, in parentheses, u is 8x squared minus 3x squared. Just like that. And that is the derivative of y. All right. So that is all I have for y'all today. Get started on the worksheet. Let me know if you have any questions.